Good afternoon, everyone. Welcome to IPDay's Webinar Wednesdays. This is Ron Cruz, your resident IPDay trainer and consultant for Math, GED, and ABE. I would like to welcome everyone, and I would like to say, first of all, thank you for spending your precious time to be with us this afternoon to learn a little bit more about the calculator prohibited indicators for the GED math module. Just so you know, we have completed our part one last week, and this is part two of this series of webinars. Just so you know, you can view that previous webinar by going in, and I'm going to show that to you in a little bit. I'm going to demonstrate how you're going to access the materials, just so you know that if you want to catch up on what you missed, that is archived and it's already readily viewable. At this time, I wanted to go ahead and cover the next 4 items in this webinar. Before we do so, I just wanted you to know as well that this webinar is recorded. So if you had to step out or you were pulled out of in case of an emergency, that you can always come back and view the archive video. It should be up within the next 72 hours. The materials, the PowerPoint, the handouts, and the worksheets that are associated with this webinar is automatically loaded into your IPDay portal or in the IPDay website. Just wanted to briefly introduce myself. My name is Ron Cruz. I am the coordinator of the Caribe Refugee Program of Hillsborough County Public Schools Adult Education. I am also the statewide trainer and facilitator for ESOL, ABE, GED through the Florida IPDay. Florida IPDay stands for Institute for Professional Development of Adult Educators. So just like what we're doing right now, we are providing this additional support for teachers that need a little bit of extra help in teaching the non-calculator component of the GED tests. So our goals for this webinar, before we go there, I'm going to just simply go over some housekeeping reminders and objectives. This is part 2 of a 2-part series webinar. Today we're going to be talking about operations on rational numbers, squares and square roots of positive rational numbers, cubes and cube roots of rational numbers, and the undefined value over the set of real numbers. I'm going to go over the IPDay website and show you how to access all of the materials, including the PowerPoint to this webinar. We'll do a quick summary, and also in the end, we would want you to complete an evaluation of this webinar. So without further ado, we're going to go ahead and get started with the housekeeping. If you have any question, at the top of your screen, you have a Q&A tab that you can click on. Click on it, a window will open. On the right, a small window will open which will allow you to type in your questions. Now, I won't be able to see your questions right away unless I open my inbox as well. So there will be several points in this presentation that I'm going to stop and look at your question, review your question, and answer them. Please note that you can also pose your question during the evaluation stage, or you can just email me if you need to. The microphones that you have right now are muted. You are only in listen mode, so you're not going to be talking on the microphone to ask your question. So we strongly suggest that you type in your comments on the Q&A section of your panel. Today's presentation is being recorded and it will be archived in the IPDay website within 48 hours. Okay, so let's go over the objectives for today. Our objectives for today is to be able to increase student performance, again, by incorporating and a little bit focusing more on the calculator portion of the GED test. We're going to talk about some strategies on how you can teach certain skills and tricks in these 4 components in your classroom. We're going to review math components and skills. So we're going to be solving, and I'm going to be modeling some solutions to certain problems, specifically the ones that are included in the worksheet that I've created for you. We're going to talk about some best practices as well as we go along, explore some resources that are available through the IPDAY website in developing lessons and covering the calculator portion of the GED test. So in continuation, we're going to now move on to Q2A, the indicator that says perform addition, subtraction, multiplication, and division on rational numbers. So you know, students hate working with fractions. And this is one of the most difficult for them skills if they are not taught in a proper way or if they're not practiced. I know that the calculator portion, students can get hung up on that calculator and think that they'll be fine if, you know, if there's 2 or 3 questions that are in the non-calculator portions that pertains to fraction, that they can just do away with those. Keep in mind that based on the most recent data in Florida, majority of our students fall 5 points below the passing 5 points below the passing score. So that means it's just a matter of 1 or 2 or 3 questions that they needed to answer correctly in order to bump them to a passing grade. And it could be one of these non-calculator questions that's getting hung up upon. So let's focus a little bit more on that. This particular component or indicator not only focuses on fractions, but it also focuses on the order of operation. So this is where the order of operation really is being assessed in the GED test. Keep in mind that these questions will not necessarily appear as, okay, well, evaluate this expression or evaluate this that expression straight. So GED is doing away or has done away with straight computation. Is usually embedded in a word problem or whatnot. So these are some of the recommendations for test takers, and I see this as recommendations for teachers as well, is to be able to multiply and divide with decimals. So, you know, try to review those manual multiplication and division of 2, 3, 4-digit decimals, just following that convention with the students. Start with easier numbers with your low-performing students, and then move them up to the more difficult numbers. Practice with your students manual computations with fractions, and incorporate the order of operations when working with fractions. So don't just simply give the students problem where you have, okay, well, 1/2 plus 3/4. Don't start with that right away. Of course, this is where you're going to introduce the addition of fractions, of course. But as you move on, don't stay with this type of problems. You need to add a little bit more complexity to the operations on fractions that you're doing. So maybe make this a mixed number, put parentheses, and add multiplication or subtraction in it, and, you know, allow the students to work through more difficult problems where they're having to do multiple computations, starting with easy numbers, just like 1s, 2s, 3s, and 4s, just like I've shown you here. Incorporate some exponents in there and see how that would change the answer. Try to give students the you know, numbers that do not have the same denominator, or fractions that do not have the same denominator, just like as this example. So force them to find the common denominator for the 2 numbers in order to perform the operation. Give them some division problems so that they will remember that when you are dividing numbers, or you're dividing a fraction with a fraction, the operation becomes a multiplication, and you flip the second fraction based on convention. Plus, and if you've been through our previous webinar, we talked about the reason why this is such. It's been archived in one of these webinars. So if you've missed on that, please look it through, and I'm going to show you how to look through all the past webinars we've done to explain why we changed the operation to multiplication when we're dividing fractions. So do that, use mixed numbers, add in some negatives in there, and so on and so forth. So here is a sample problem. They're pretty complex problems, practicing students with the order of operations, mixing some exponents in there. Then there's a fraction in there. Looking at the second problem, we have a zero exponent, incorporating some of those rules on exponents that's already in there. And then on the third one, just re-emphasizing to the students the difference between 3 times 1/2 and 3 and 1/2. You know, sometimes students get confused with that operation. Okay, so let's start off with this first problem. Okay, so when we're working off, again, I usually tell my students use this acronym. Stands for, you know, it's more commonly known as please excuse my dear Aunt Sally. It stands for the order of operation, how we're going to do the exponents. So we start off with parentheses followed by exponents, then multiplication and division from left to right, and addition and subtraction from left to right. So let's start off with here. I see here I have a parentheses, so I'm going to work off this portion of, oops. Okay, it started flipping through. Let me go back. Okay, sorry about that. I accidentally touched the screen by my hand, so it moved on. So we're going to be working off of this one first. So if you're doing that portion, you wanted to do 4 minus 5 squared. You wanted to do the exponent first before subtraction, because then within this parenthesis, you still have to follow these guidelines. So within the parentheses, you're going to apply PEMDAS and then do the operation indicated. So in this case, this will simplify to 4 minus 5 squared is 25. Okay, something's going on with my pen. Okay, right there. So we just copy everything here. And then you can simply do the subtraction already from the numerator. So this will simplify to 3 times negative 21, keeping that rule, over 6 minus 6. Okay. All right. And then after that, I usually tell the students, when you're working off of a fraction and there's so many numbers in there, try to see if you can cancel as much as possible. What I don't want the students to do is to cancel the 6s. However, again, they go by term by term. So if we're looking at this term, is there anything in here that can cancel out? That's a really good technique because it simplifies and makes your numbers smaller as you go through, and therefore allowing you to work faster in your computation. So in this case, I'd see a 3 and a 2 here, so I can simply cancel the 3 out, substitute a 1 in there, and then the 6 will become a 2. So you're dividing both the numerator and the denominator by 3. Okay? So in this case, this simplifies to, so I'm going to move up over here, this simplifies to negative 21 over 2 minus 6. All right, so a lot of the students at this point, you would be surprised, are still going to struggle at this point now that we've really simplified the question into a fraction minus a whole number, let alone there's a negative sign up there. So now we're at the point where students have to figure out, okay, well, what would be the denominator of 6? Or how can I turn the whole number 6 in such a way I can simplify this? I've seen some students do this. They tell me, oh, all I have to do is do cross multiplication. I've seen that done by many students. You need to watch out because students can easily get it wrong if they don't follow through and become consistent with the process. So if some students will do this, so we'll keep the denominator the same, keep the negative 21, and then multiply the 2 by the 6, okay? and then call it like that. Okay, so that is still mathematically sound. Then what would teachers do would be, and then we'll figure out a denominator of 2, and then um, you're gonna figure out what numerator should be up here in such a way that when this fraction simplifies down to a 6, and that would be a 12, because 12 divided by 2, it comes down to a 6. So you can do that process. There's also excuse me, there's many different techniques, and teachers have used many different techniques for students to simplify or subtract fractions with unlike denominators. So just be careful, allow the students to be consistent, because what some students do is would simply multiply the 2 to the 6 and then call it a day and subtract it from negative 21. So they still need to keep the denominator the same or as a 2, and then now we can evaluate negative 21 minus 12 is negative 33 over 2. So that is the final answer onto this question. Okay, so moving along, there's going to be on this second problem, it would be advisable, what I tell sometimes my students, if you see an exponent outright that simplifies by itself, there's nothing wrong with not following the PEMDAS, because this one students will automatically recognize, oh, any number raised to the 0 power is 1. They can automatically do that as long as it's not embedded within another operation. So in this case, the 3 to the 0 is all by itself. It's not within the parentheses. So students, I would immediately tell the students, just eliminate that that number with an exponent and with an exponent of 0 and substitute it by 1. Now we can work off of the middle section of this because we're working off the parentheses. So from the parentheses, I don't see any exponents. I don't see anything. So I'm just going to go ahead and perform the subtraction. But again, we run into the same problem. This do not have the same denominator. We're subtracting a fraction from a whole number. So if we apply the same technique as before, so the denominator will remain as a 4, and then you're just simply going to multiply the 4 to the 2 to get the first numerator, and that will get you to an 8, and then subtract, and then you will just simply copy the numerator of the second fraction. Keep in mind, we still have to bring everything down, and this time, as you can see, I'm just simply bringing down the 1 instead of the 3 to the 0. So from this point, we're back to the same technique. We work off of the numerator, 8 minus 3, that comes out to the 5 over 4. Multiply that by negative 2, and then add the 1. So we're just bringing everything down, making it short and simple. Again, following the guideline or the technique that I tell my students, if you can cancel at some point in time, go ahead and do that. So from this step, I can see that the negative 2 and the 4 can cancel out. They have a common factor, which is a 2. So therefore, if you divide the numerator and the denominator by 2, you're going to get 1 and 2 over here. So I can simply write that as 5/2 plus 1. And then as soon as we realize, oh, I have to do that again, oh my goodness. When you're adding or subtracting to a 1 or a whole number with a whole number 1, it's, I tell my students, don't get intimidated with that, because you can always substitute the 1 by your denominator. So some of my students would do this: 5 over 2 plus 2 over 2, because they know 2 over 2 and 1 are the same numbers. So moving along with that, they can follow that, or they can follow the same technique as before. We multiply the 2 to this whole number 1, but keep the denominator as 2. Okay, wait a minute. I forgot the negative sign. So there is a negative sign here. So this is negative 5 over 2. I forgot that. And then that's it. And this is a 2. Okay. All right, got that corrected. Sorry about that. So now that we're at this point in the problem, you can simply perform the operation at the top. So negative 5 plus 2 is negative 3 over 2. And this is the final answer for this question. Now the last problem simply illustrates the difference between 3 times 1/2 divided by 3 and 1/2. So this one is a mixed number, and where this one is a multiplication. In here, again, I tell the students, it's either you only multiply it with the numerator, or you write the whole number as a fraction and then perform your multiplication. So in here, you multiply across. So this comes out to 3 over 2. Okay, that's too low. So let me do that over here. That this comes out to 3 over 2 divided by 3 and 1/2. Now our next step is to convert the 3 and 1/2 into an improper fraction. Because remember, when we're doing multiplication, you are going to change the operation to, when we're doing division, you're going to change the operation to multiplication and then flip the second fraction. So in here, it's very difficult to flip if it's in a mixed numbered form. So we got to change that mixed number. I'm going to go ahead and change the operation to multiplication. And then this one comes out as 2 times 3 is 6 plus 1 is 7/2. Okay, and then so as we multiply, this will come out to 21 over 4. Okay, so any questions so far? So I'm going to pause here a little bit and see what we have questions. Okay, so we have some questions over here. We're looking at number 3 right here. So let me look back. 3 over 1 times 1/2 is 3 over 2 times 7 times 2 over 7. So I forgot to flip here. So it's 2 over 7. So then you multiply that across, that would be, okay, so let me erase that. That will be 6 over 14. Okay, it won't erase it here. Something's going on with my... So I'm just going to go ahead and, oh, it went into highlighter mode. Okay, so it's, we're just going to go ahead and just do 6 over 14. And then that further simplifies to 3 over 7. Okay, so we're moving on to the next competency. The next competency is performing computations and writing numerical expressions with squares and square roots of positive rational numbers. This indicator tests one or more of a number of skills. Certain things that they're going to be testing here is squaring a number, taking the root of a perfect square, simplifying and computing with non-perfect square roots, and computing with square roots and other rational numbers in combination. More than taking the square and the square root of a perfect square, it's really, and then taking the square root of non-perfect square roots, students struggle a little bit more when it involves a combination of several different computations in a particular problem. So again, applying the order of operations in combinations with squares and square roots. So that's where the performance really drops off on the GED test. So let's look at that. So some of the recommendations are in here are first memorize the first 12 perfect squares. So again, just have it on the board, create a poster, line them up, or put them on the number line, as many ways as you can illustrate perfect squares to your students. Try that. Sometimes I would use a geoboard to just illustrate what a perfect square looks like. Understand the relationship between squaring and square roots, okay? And this is where I'm going to get into, okay, what is the principal square root? Okay, and then the square root, if an operation in an equation, let's say, for example, x squared is equal to 4, when students are doing and trying to solve an equation that involves an exponent or a power of 2, in this case, we always suggest to students, okay, this is the best way to do that, deal with that problem. Take the square root of both sides. And so therefore the square and the square root will cancel out on each side. But what students often forget is that the resulting number is a positive or a negative number. So it has to have the plus minus symbol in there. So in this case, it'll be a plus and minus 2, because going back to the original formula, to the original equation, in this case, x squared equals 4. If x is equal to 2, so 2 squared, that's equal to 4. And then if x is equal to negative 2, that will still work. So negative 2 squared is also a 4, because a negative 2 times a negative 2 comes out to a positive 4. So this is the part where students forget the most, is to write the plus and minus sign when they're solving an equation that involves exponents or involves taking the root of both sides of the equation. So let's look at that. This is another common misconception of students, is that when the numbers, when the negative confuses them in this case. In this case, if the negative is enclosed within a set of parentheses, that means that translates to, and I'm going to write it in here, this one translates to negative 3 times negative 3. But in looking at this second example, this is not the same as the previous example, just because in this case the negative is not being included with the operation of squaring. So you will keep the negative sign right here, and then you do your squaring. So this top portion will come out to a positive 9, whereas this one will come out to a negative 9. Like this, initially, students may want to write it like that, or would go straight to a negative 9. So it's important to show that differentiation with the students, because they would always think, oh, this is the same thing as that, and that's not the case. That's not the case. That's not how you will deal with that. So practicing with students with the use of parentheses and exposing them to the numbers with and without parentheses is very, very important. And then simplifying non-perfect square roots, just like an example here at the bottom. So square root of 12 can be rewritten with its factors. So so you can rewrite 12 as 6 times 2, but that won't do you any good, because 6 and 2 are not perfect squares. So I tell my students, you have to use, that's why memorizing these numbers are all important, because it makes them proficient in simplifying non-perfect square roots. So that means they have to figure out factors of that number that are either one of these numbers, so one of the first 12 perfect squares. So in this case, 6 times 2 will not work, what would work better would be 4 times 3. So now I can take the square root of 4, and then as I evaluate the square root of 4, I take the number 4 out. That's why it comes out to 2 square root of 3. So let's look at some examples here. All right, so keep in mind again, they will not have questions that straightforwardly asks, what is the square root of 9? Or what is the square root of 24? It will not be straightforward like that. It would either be embedded within a complex string of operations. It could be evaluating a number, or they will evaluate the expression given the value of x as a particular number. So they can do many different things. They can ask them to find the square root of a non-perfect square number with variables. So it could have been, okay, well, it could have been just the previous example, 12m squared n to the fourth. It could be like that, and they will apply the operation in that. Or that could be embedded with the problem or a word problem. So I don't want you to get confused with that. That's just an example. So let's just go ahead and straightforwardly use. So this first one is straightforward, square root of 9. Students would automatically come up with the number 3, and then you ask them back. Ask them, the students, why do you think? Why did you say that the square root of 9 is 3? Students will have to be able to say, well, because 3 times 3 equals 9. So then, okay, so let's talk about this square root of 24 and see what we're going to do with that, because that's not a perfect square. So students usually will brainstorm as a class and brainstorm some factors that would help us. So students might have an example. Let's say 12. Oh, my PowerPoint just moved on again. Previous. Okay, so students can say, okay, well, let's try, is 12 times 2 working? No. Or how about 8 times 3? Not really. Okay, well, there's another one. 24 times 1 will never work. So let's try, how about 6 times 4? Oh, maybe we have something going on there, because now you're using the number 4 as one of the perfect squares. So definitely we can work with that. So let's start with that. So square root of 24 is equal to, I usually put the number that has a perfect square right up the front just for consistency, and it reminds the students that 4, when you evaluate that will disappear, and then the square root of that number will be right outside the square root symbol. So that's 4 times 6, and then we take the square root of 4. So the square root of 4 is 2. And you cannot take the square root of 6. Neither do you have any factors of 6 that can be further broken down into at least one of them being a perfect square. So 6 will remain inside. I usually teach taking the square root of a number. Usually talk about it in terms of like jail. I did it in some of my workshops that I did throughout the state. Sometimes I tell the students, okay, well, think of that number. Let's take the number 4, and then if it's underneath the square, that number is in jail. And the only way that it's going to be able to get out of jail, and we're talking about the square root symbol or radical sign, the only way to get out of jail is for it to be a new person, or to be a renewed person, for that number to change. So pretty much. So that's why when the 4 gets out of the square root, because it's a perfect square, so then it'll become a 2. Now, if we talk about like, okay, well, these numbers usually they're inside the jail. Those are the numbers that can no longer, if it cannot be broken down, those are the ones that stay in jail. So the people that are in jail that do not want to change and they can no longer change, they have to stay in jail. So students pick up on that analogy, and it makes them remember certain things. They remember especially process of simplifying non-perfect squares. So in this case, the number 6 will have to remain in jail because it can't change to a different person to get out of that radical sign of get out of jail. Okay, it's okay. This time we're going to talk about the next problem. So in here, okay, well, I don't see any parentheses here or whatnot. Unless the parentheses is there, it will not force you to include that negative sign when you're squaring, okay? So unless so that means that the negative sign will be retained and you're only doing the squaring with the number 4. So 4 squared equals 16. So the final answer in this case is negative 16. All right. Now we go to radical exponents. So keep in mind that the highest denominator, the highest number that they can use in the GED as a denominator is a 3, because that's the only, that's as far as GED would go. They would go up to cube roots, okay, and cubes, which we're going to talk about in the next competency. So in this case, again, we're working off of a radical exponent, a rational exponent. So when you're working off of a rational exponent, I tell the students the number at the denominator, the denominator of the exponent is your root, and the numerator, so this is your root, and then your numerator is your exponent. So I asked them to just label that first and then rewrite it as a radical number, okay? So, okay, so I'm going to put the square root. Students can always put that 2 up there. Keep the 4 because 4 is your base, and your 3 is your exponent, just like this. So you read this as the square root of 4 cubed, or the square root of 4 to the 3rd power. It would be, students would work off of the 4 to the 3rd power. First, work everything inside the square root, trying to find any ways where we can do that. And then that's 64. And the square root of 64 is 8. Now, students would sometimes students would not be at that point where they can easily remember, square roots, especially bigger numbers. So I tell my students, okay, well, we'll try something else. So let's do this. You can break down the 4 cubed into 4 squared times, 4 squared times 4. Okay. And then we're following the same guidelines as we talked about inside of the jail, outside of the jail. I usually do say that this 4 squared is a perfect square. So when you take the 4 squared out, it would still be a 4. It only eliminates, the square root eliminates the square. And then the 4 remains in jail. But in this case, if I want to simplify this, because the number 4 can also come out of the jail or the radical symbol. So if you take the square root of 4, it has to be a renewed person, so it'll be 4 times 2. And that comes out to 8. So either way, students will be able to work off of this problem using multiple methods. And then lastly, I want to talk about this one. This one is just showing you the one with the negative is forced within squaring. So when you do it like this, you can simply just tell the students, just write it twice. Okay, you can do that. That would be your safest bet. Or if, and I tell the students, just square the fraction and then change the sign to a positive, because remember that when you multiply these two, the final answer will be positive because you have 2 negatives. A negative times a negative is positive. So in this case, some students would do this though, 3 squared on 4 squared. So some students would distribute that power to the numerator and the denominator. That is a property of exponents that you can do that. So in this case, if you simplify that, That's 9 over 16. So I'm going to pause a little bit here and look at your questions. Okay, so I don't see any new questions being asked. Okay, so I had a question here that's being asked about this problem right here. Oh, it keeps doing that. About this question right here, this particular problem. Again, keep in mind the negative sign. If this had been -4 squared, that comes out to -4 times -4, which is 16 positive. But in this case, there are no parentheses that's indicated here. So that means the negative sign is a little bit separate. It's not included in the squaring process. So you have to square the number 4 first. 4 times 4 is 16 and tag the negative sign along. That's the reason why this is our final answer for this third problem. So that's the question I have. Somebody asked me to go over. And again, if you have a question you don't understand, I can go back to these slides if we have time in the end. So I'm just kind of move on a little bit here. So we're going into this indicator. This time we're going to apply the same thing with cubing. So same procedures, same things students are struggling with. They can do cubes and cube roots, but the problem is when you mix them up with other operations, that's when they start getting confused. All the more we have to teach them working off different problems using these cubes. Again, same, they have this very similar recommendations. Have the students memorize the first 6 perfect cubes, just so it makes the computation a little bit easier. The difference between cubing and cubing and squaring is when it becomes negative. So if you cube a -3, the answer will still be a negative number, because when you cube in here, when you cube a -3, that is -3 times -3 times -3. So the first operation, multiplication, changes that 3 to a +9, and then you still have that one negative remaining there. So 9 times 3 is 27, but again, because this 3 is a negative, your answer remains a negative. So that's the main difference I show my students when you're cubing, as in contrast with squaring. So in here we had some problems. We're just going to work through this a little bit quickly. So again, this can be rewritten as 6 times 6 times 6, which is 216. The second one, again, you can rewrite this problem just to be safe. I see the parenthesis sign forcing us to include the negative with the cube process. So this is -4 times -4 times -4. So just as illustrated earlier, once you multiply all the 4's together, your answer will still be a negative. And in this case, it's -64. All right, so again, this is cube root. So let's talk about cube root. So the cube root of 8, students normally do this, because if you do this enough, they normally know what this cube root of 8 is, and they would say, well, that's 2. Okay, so if it is 2, and then I ask them why, well, so that they can explain that, well, because 2 times 2 times 2 equals 8. So I always review that rule with them as to why when justifying, when you're trying to find the cube root. Okay, so again, keep in mind that we have to memorize all of the first 6, have your students know or by heart or memorize the first 6 cube roots or perfect cubes. And that would be most useful in this problem. So we're trying to find the cube root of 16. So no 3 numbers multiplied 3 ways, to itself 3 times, would result to 16. So we need to break down 16 as we did the square roots earlier. And since we already have that clue that we did the 8 earlier, so I can break down the 16 into 8 times 2. And the cube root of 8 is 3. I'm sorry, the cube root of 8 is 2. And then the other 2 will remain inside. Okay, and then lastly, this one question. Oh, it's a negative. So again, the denominator is your root, and then your numerator is your exponent. And then let's rewrite it in a radical form. So in radical form, this will be the cube root of negative 8, forcing that parentheses in there, and then squared. So this is the cube root. So when we evaluate that, our answer would be positive number, which is 64. And the cube root of 64 is 4. All right, so I'm going to pause here and look at some questions real quick. Okay, I did. Yes, I forgot the 3 right here. Thank you for all of your reminders. So let me go back here. I forgot that this is a cube root problem. Very keen eye, guys. Very good. Thank you for all of those reminders. We want to make sure that these are correct. Keep in mind that I did provide an answer sheet for these questions that you can look at and then use in your class. Okay, so lastly, undefined. One final word with regards to undefined numbers is what we're trying to avoid, because the scope of the GED test is only numbers that are not all the scope of the real numbers, but rational numbers. You should be avoiding a denominator of 0, okay? So just like as it's stated here, fractions with 0 denominator. And then we're trying to avoid imaginary numbers, because that is not included within the scope of the GED test. So we're staying away with imaginary numbers, and we're staying away with undefined numbers. Okay. So let's look at some of the questions here. So that would, and I also yeah, I also wanted to go over some recommendations here. Some of the indicators for my students, I tell them if it's a 0 denominator, it's undefined. Fractions with expressions equivalent to 0 in the denominator. So eventually, even if I have a fraction right here, let's say 5 and 3 minus 3, that's still undefined because this works out as a 0. Square roots of negative numbers, so the square root of -4, okay, is we're trying to avoid that, and it is undefined in the set of real numbers because it's an imaginary number. But how about the cube root of -8? Should we avoid that? So is that within the scope of it? So that's something that we are going to, it's good to think about, okay? Because this one would still be a -2. So let's talk about this next one. Some of these questions here. So let's solve this set of real numbers. So this again is talking about a 0 in the denominator, or fractions that resolve to have a 0 denominator. So I added in some exponents in there just to review some of the exponent rules and things like that. So if I rewrite this, this is -3, 8, copy the 8, and then evaluate the -2 to the third power. So 2 to the third power is 8. So right here we can see that this comes out to 0. So this is now undefined in the set of real numbers. So let's look at this. Let's look at the second one. Again, let's evaluate the numbers at underneath the radical symbol. So 2 to the third is 8. And 3 squared is 9. So that's 8 minus 9 comes out to a -1 underneath the radical symbol. So if you have a negative under the square root sign, that is not defined over the set of real numbers. So this is undefined. And then same thing is here. It may appear like, okay, well, at first look, it may appear, oh, this is legitimate. It could be, or whatnot. So sometimes they will hide it into an expression and ask the students to evaluate it with a particular number. So in this case, if we have the square root, and then we're going to substitute 1 for the x, so this is 1 minus 3 times 1. When working out of the 3 times 1, this comes out to 1 minus 3. And then 1 minus 3 is equal to the square root of -2. So again, this is now, it is undefined over the set of real numbers. And then lastly, same thing, is kind of like a similar problem as our first problem. You have an expression over here, and you're trying to evaluate it when x is equal to -3. So we'll simply substitute -3 to each of the x's. So in this case, you want to put your -3 in parentheses. Okay. And then -3, again, we've dealt with this problem already. So this comes out to a 9 minus a 9. This produces a 0 denominator. So this is undefined. It's good to show students different ways to how this will occur. It's also good to show students that if it's a perfect cube, that perfect cube can be a negative. So it's only we're looking out two major incidents where a number will be undefined over a set of real numbers. That is when the denominator evaluates to 0, or if the number under the value under the radical sign comes out to a negative number. So let me show you a little quick overview as to how you're going to access these materials when you log into the IPDAY website. Want to keep that. So if you log in, if you go into your IPDAY website, you don't even really have to log into your portal to access to the webinar materials. All you got to do is go into the middle section, and you hover over, you click on GED, and then this is a webinar. So you click on the webinar section, and then you can see right here, GED Calculator Prohibited Indicators Part 2. So just in case you have missed a portion of this webinar, you can click on here. Usually in this section, on the right section of the screen, then I'm going to draw right here. In this section of the screen, you will see a video with the play button in it. And that's normally how it looks. But now, after 48 hours, our tech team from IPDAY will be uploading this video into the website so you can view it again. Over here to the left section, you do have the PDF presentation file. So if you want to look at the slides again, there is a blank worksheet that I created in there. And also, I put it in a separate answer sheet in there. And then in the recommendations handout, the actual document that was released by GED Testing Service. So that's how you're going to do that. Now, if you missed the calculator training part 1, I can show that to you too. So going back to resources, going to GED, clicking on webinars, and then the part 1 is right underneath. So they're right next to each other. I think this is archived by date. Okay, and just going back to our presentation real quick. So, in summary, we've explored some test taker recommendations, what GED testing service recommends teachers should do or students should practice. We've reviewed some pertinent math concepts here, looked at some non-calculator questions, and then we've talked about some best practices and explored some resources that will help teachers develop some good problem-solving techniques. Okay. I have some questions here that goes back to the previous slides. I have a question from Miss Cheryl Ward and Miss Susan Mershon and another anonymous viewer. I'm going to take note of these questions and then answer you, email all the participants regarding the questions here. Okay. So I'm going to answer these questions after the webinar. Some of these are... Okay, so I did see that on the slides, it was not flipped. Okay. All right. And lastly, I want you to take a moment to scan the code in front of you. If you have a QR code scanner, if not, you can use the PowerPoint slides that I gave you. Follow the link, copy and paste the link, or type the link into your browser to go into, and please complete the survey. We do really value your participation and your feedback in these webinars. Hopefully I was able to provide you with some useful information that you can use in your classrooms. Hopefully I was able to review some of the math concepts so you can use the worksheet that I provided with ease when going over these techniques with your students. What I really suggest is not to teach non-calculator techniques independently. What I mean by that is just like you don't teach grammar in isolation, you don't teach computation skills or mental math or non-calculator skills independently. It has to be embedded with the other maths that you're doing. So in your lesson, when you do a complete lesson with the class, of course, allow them an opportunity to use the calculator, to practice the use of the calculator in the lesson. But also every now and then, maybe in the middle of the lesson, do a question where you don't want your students to use the calculator, just so you're always practicing the non-calculator skills throughout the day, every day, so those skills do not go away. So that's my biggest suggestion to all of the teachers and the participants of this webinar. Hopefully you were able to take some really good suggestions and feedback from our participants here. I do wanted to go back to the slides. I will be correcting that slides or on the PowerPoint, the unflipped fraction that was somebody commented earlier. So again, I thank you everyone for being participative today and staying engaged in this webinar this afternoon. I really thank you for your time. On behalf of the Florida IPDAY team, we wanted to say thank you. Please don't forget to follow the link or copy or paste or type the SurveyMonkey survey into your web browser. Complete a quick 3 to 4 question survey. Again, your feedback is very important to us in order for us to be able to provide some really quality webinars for you in the future. Thank you and have a great afternoon.